Hello everyone. If you are working with data, no matter in the data pipeline where you find yourself working, whether you are doing the exploratory data analysis or you are working with the data when it is ready to perform operations on it, such as performing the machine learning training on the machine learning ready data, or the data is coming to you where your responsibilities are to perform the inference. You understand the value of good data, valid data, and the implications of bad data. In this tutorial, we are going to take a look about the great Python library called Great Expectations. Using the Great Expectations library, you can perform the data testing, data validation, data profiling, and data documentation all together, and in a very reusable, human understandable format. And you can extend this Great Expectations library to match with your domain specific data. So this Great Expectations library could be a very useful tool for you to know while you are working on your data related requirements. So hello again, my name is Avkash, and in this tutorial I will going to give you more details about what is Great Expectations tool, why it is created, and why it can be a very beneficial tool for your data related work. And I will show you variety of examples so you can get yourself started with Great Expectations tool. So let's get started. Before we start our tutorial, let's take a look at the Jupyter notebooks which we are going to use in this tutorial. The Jupyter notebooks related with this tutorials are located at this public code repo, and in this public code repo there is a folder Python and Great Expectations work, and at this page you could get all the notebook tutorials which you could clone it and use them as needed. The notebooks are already ready, up and running. The notebook server is running at my local machine, and let's get started with the introduction to Great Expectations. So first thing first, you would want to know why Great Expectation. Or if somebody just start the conversation and say, give me the one-line introduction to Great Expectation. And I would say the answer is that it's all about data testing. We have already done testing, software testing, A/B testing, variety of testing last 20-30 years. And the question comes that what if our data itself is not right? So anything what we do is not going to work. And one good example is machine learning models. Your models are working, everything is going well, and suddenly your models are not responding properly, means the results are not expected. Very quickly, you have to look around everywhere and see where could be the problem. What if you could have a data testing framework built into where all the new coming data has been validated for its correctness? It means the values within a column are within the range. Outliers are clearly identified and removed if there are. The correlations between the column relationship label is expected or not. So several things can be tested at the data level itself before we try to look the problem elsewhere. So Great Expectation is a great tool where you have ability to create the human readable syntaxes related with your data. It means that some of the data is common across several verticals, several organizations, then the existing library is going to work. However, if you have a problem where your data is very unique and you would want to create the data validation and data testing modules, you can extend the Great Expectation framework and you can build the rules according to your data validation scheme. And that's one of the great thing about great expectation. So why great expectation? So the based on great expectation team, feedback is that most pipeline complexity lives in data, not in the code. How we are processing the code, how the code is really processing the data and generating further downstream details related with the data or analytics, etc. However, the data itself has to be looked upon. Data pipeline are full of bugs with soft edges, and basically that we are not doing enough job in order to validate and maintain the data integrity as requested or expected for the problem itself. Insights get left on the cutting room floor. It means that people who are working on the data, or those who have the domain expertise in the data, their work has not been integrated successfully. A lots of the knowledge, a lots of the details related with data itself are not being integrated and remove the productivity cost and operational risk. So great expectation is needed basically because down the road, if you are going to hit the problem that is basically coming out from your data integration pipeline mishaps. As you are going to go down in the pipeline, you are going to have several other problems. So isolate them, rectify them before they are even a problem. So what is great expectation? Great expectation is a flexible declarative syntax for describing the expected shape of data. This line is very important. If you know the column is age, and if you would say that age is definitely where it starts and where it really ends, age cannot be more than 160. You understand that's where. So if you want to write a data validation scheme for age column, you know that date must start from 1 or 18, whatever your data centric view is related with age, but max should not be like that. And that's where the data shape is coming into the existence. Looking into the date, where the date validations are, looking into the values, amount, what is the highest, what is the lowest. If you are looking into the labels, are these labels within these label categories? If the data itself, if the strings are there, whether they are mature, whether they are correct or not according to your data. So there could be several things related with the shape of your data that has to be understood and added into your pipeline itself. Data pipeline testing tools at development and production level. So great expectation really works both places, where the development and as well as the production level. It means when you are working on your data, you can create these scripts, everything goes well, and then you take those scripts and you can apply in production level. It means when the new incoming data is coming, your scripts are applicable over there and they will immediately perform the validation for you. The next, in the exploration phase, documenting latent knowledge about the shape, format, and the content of data. That's where the great expectation is really very powerful. Depending on which vertical you are and which business you are and what kind of data you have several shape, format, and content of your data. So when you are doing exploration of your data, at that time, you could all that information can be documented very well, because that's all about the domain expertise. If I'm the DevOps guy, if I'm the MLOps guy, I do not know anything about that data. So if there is some expert in the team who actually document all those requirements, validation rules, etc., they all can be integrated through the machine learning pipeline or down when the MLOps have been working. In the production phase, expectations are powerful tool for testing. When the data is coming and you have a whole production pipeline, all is functioning well, these expectations, basically the report, basically the configuration related about your shape of data, content of data itself, they all can be very powerfully used for testing, validation, to prove that data, incoming data is valid. Implication of that valid data can be validated very nicely at this point. enabling teams to quickly zero in on potential errors and determine how to respond. So if you know that these data configurations are available in your production pipeline, very quickly these reports is going to tell you that where the potential problems are. You can zero in those problems and solve those problems. In English, please. It means somebody who does not understand a lot this thing about technology, problem, data itself, how you can explain them in layman terms. So the first statement is think about data testing. The value you see in your data as per your expectation. So if you are a data wrangler, you are working on data and your expectation with the data is as such is that as such is really available in the data or not. If you are selling items and those items have a defined terminology, you can create a regex rule and make sure that does the column follow that regex rule or not. So all that data wrangling you already do as a data wrangler or as a data engineer when you are working in your organizational data pipeline, they all can be written very clearly. And they once written, they can be reused again and again and again in really very reusable and can be understood very well and can be explained to somebody else also. In general, it's basically the assertion about your data. If this doesn't happen, flag it. Let me know if it's error or not. And these assertions in Great Expectations tool is basically a declarative language in the form of simple human readable Python methods. So you create a Python method and you will say, if my data has min this, max this, and it's come between that category, flag it, or if it's a true or not. Or if you have a very large amount of data and you can say that I can live with 80% of these 80% of good values, and if there are 20% bad values, I can live with it, or 90% or 99%, depending on what is your threshold of acceptance in errors with related to your data, or if just not acceptable at all. So that's how you can understand the Great Expectation as a tool. It's a data testing tool, and it's done in a way that it's reusable, it's explainable to somebody, and it can be used on a variety of places in your data pipeline or your ML pipeline or wherever you are trying to process this data within your organization. So conceptually, Great Expectation is similar to automated data profiling. For example, if you have used the Panda data profiling or Panda profiling, you have seen that very quickly profiler runs on the data and it generates an interactive report about your data. Here you are going way more deeper in your data to get what you are looking for. It's kind of data validation as well as also the data documentation. And that's where the power of Great Expectation can be realized, which is very latent at the start, but if you think about it, it's really very powerful because we have this terminology called the domain expertise. If you document your data very well, basically you are making the domain expertise easily exchangeable to someone else. If somebody who could understand this whole data documentation, they can be the domain expert as well. So the path for domain expertise can come from Great Expectation like tools. If you are interested more about learning the origin of Great Expectation tool, this is the article available at Medium. Please visit yourself. So now we can take a look into very quickly that, okay, what is this Great Expectation gives us? So remember, we talk about a declarative language in the form of simple human readable Python method. And here is one example. So here say expect column values to be between. So column name, min, max, and mostly. It means you need to tell that for given particular column, what is the minimum value and what is the maximum value has to be. So value should be in between there, and mostly 95% of the time. So mostly is also given. It means that more than 5% of value fell outside the specified range of 60 to 75. It means that when this whole data will be validated based on this rule, it will also check that, okay, what percent of data comes within the given boundary and outside the boundary. So it's a very good way to look into. It means the outliers are already being thought upon. The bleeding edges where the data is gonna bleed out are also thought upon, and that is where the power of domain expertise, who understand the data very well, comes into that. There are several other tools available for different purposes. So for example, in R, there is a tool called assert R. In the TensorFlow data validation, I'm working on a really great video on data validation. Soon that will be available at my channel as well. So very quickly, we understood what is great expectation. Now we can go and look into the little more deeper and technical part of great expectation. In this next step, we will look into just a very quick the great expectation package installation. As you could see here, I already have the great expectation version 14.9 installed in this machine. So if there was a newer version available, I try to upgrade also. So I do not see that newer version was available. And just for FYI, at this machine where I'm running this great expectations tutorial, the Python version I have is 3.812. So here is my Python version. And when you are trying to look into the great expectation, here is, you could figure it out, what's the great expectations library version you have. So this is the latest version I am using in this machine. So for the beginners, this is how you could install the great expectations in your Python runtime environment. In the next step, we have to learn about the initialization part of great expectation. Because when you are using the great expectation tool, it's designed for end-to-end data pipeline. It means you can use great expectation while you are creating your data pipeline, you are doing the EDA, you are performing the exploratory data analysis, you're writing rules, etc. And then this configuration will be used with the subsequently when the newer data come, which is not being processed yet by the data engineers or the data domain experts. So that whole design is really needed in order to make sure you could use great expectation all the way. For that reason, once the great expectation is installed in your local machine, that has to be initialized, where you could define how you would want to look into the various sources of data available in your data pipeline. So very first, we are going to import the great expectation library in Python runtime. And here I just wanted to show you that in this machine, I already have the great expectation initialization is done. And that's where you need to initialize it. So here you could see that great expectations in it, and that command I ran at my command line. And when I ran that command, that was the output. As you could see here, it's okay to proceed. And as you could see here, it shows the YML, where the configuration of great expectation tool is. Here are various folders, and here is the uncommitted folder where again you are going to see some of these document. So you say okay, yes, and that's how the initialization of great expectation is going to happen in your machine. In my machine, as you could see, we have great expectations, and here the content inside. If we are interested to look into the details about this great expectation YML, and here you could see that this is how the configuration of great expectation look like. And reading this is going to help you immensely the architecture of great expectation tool itself. So initialization is done. Once you initialize, you will have that folder. So I do have a little more detail about what you need to do after the initialization. And that's where we call it context, how to get the expectation context. So here is the URL which you could study if you need more details which are not available in this tutorial. So what is the data context? Okay, and throughout in your data pipeline, wherever it's used. So very first thing, you are going to set it up where the location of your data is. If there are plugins and data dictionary documentation, anything needed, that's part of the setup. Then after, you are going to connect with your data source and you are going to read this data. So when you are going to read this data, it means there are a variety of sources could be available. Data could be available on the disk. Data could be available on the SQL server. Data could be available on an object store, such as Azure Blob Storage or Amazon S3. So variety of locations where your data will be there. So you need to configure it, and so that your great expectation processing can read that data. After that, you are going to create the expectations, and here the expectations are, you are creating the expectation, and expectation will give you the result, content about the data dictionary, what you have created, and everything related with that. And same time, whether you are at the exploratory phase or when you are using the configuration to validate your data, in both places, you are going to get results in the form of metrics, validation, true, false, and percentage, etc., depending on if there are errors. In validation data, that's a checkpoint. That's a very good feature. And if you remember when we were looking into the initialization part of dictionary, here you could see these are the validation, and here also you can see the checkpoints folder. So checkpoint folders are basically that when your incoming data is coming and when you are performing the data validation, you can build these checkpoints. So you will know that these checkpoints mean these validation results are from that time. So there is a very good way you have a tracking built into that. If there is a decay in data or if there is a change in data, at what time that change was introduced in your data pipeline. So this image is a really very informative image for you, and I would suggest you to look into more as needed in the documentation section of Great Expectations. Here I am importing the Great Expectation library, and that's after that I'm getting the context. And if you do not have initialized your Great Expectation library in this, where in the runtime wherever you are using, you will get error. So you have to initialize it. Once you initialize, that context will be read. So here you could see that here is most of the information what you are seeing is actually being configured, and that configuration is coming out from those folders which we have seen earlier. So if I look into this, I would say that so this is where some of that information is coming into, where the configuration related. So here you could see that as by default the enabled is true. It means the anonymous usage statistics are being sent from my machine or my runtime to the Great Expectation server. So at home is built into, the checkpoint store is there, and the configuration variable, lots of properties related with configuration are added here. And reason this is very simple, because I haven't added anything. I just initialized, and that's the base or the vanilla configuration related with Great Expectation is added in this machine. So I'm working on another tutorial where I'm creating a brand new expectation for a certain kind of data, and there is a whole tutorial available for that. So that tutorial is going to go more deeper into these configurations. So that's why I am not going deep into that, because this tutorial I just want you to learn about Great Expectation. You get an idea that why Great Expectation could be a great tool for you if you are working anywhere in your data pipeline. And here, if you would want to change any of the parameter in your configuration related with Great Expectations, here you could see that this is the change. So you can just go ahead and you can open the YML. There are YML editors available. You can use them and you can modify everything. Here you could say that where your data source is coming. You can say data source is actually a SQL, or data source is actually on a disk. And you can also tell that data sources actually could be a blob storage. And that's where you see that anonymous usage statistics is enabled true. And if you want to set it up, you can do false, save your YML, reinitialize it, and that will be your part, change your expectation context as you are going to change the great expectations configuration. As of now, we have understood installation part, and we also look into the initialization part, and then we also get the idea about the great expectation context. This is a good time for us to take a test drive about great expectation library itself. So here we are starting the great expectation test drive very quickly. So I'm already importing the pandas and great expectation libraries for this Python runtime. I already have the source URL, and the source data is a very popular data. Almost everybody in data science community or any data related community knows about Titanic dataset. And because that dataset was really very useful to explain a little more about the great expectations, so I have used that. So if you are using the pandas library, you could have used this way. You could have started as a pandas.read CSV, and this is your data frame. And you already know that this is your pandas data frame. You already know this part very well. So if you are using the great expectation, as you could see here, there is a great expectation, and you could read and source. And as you could see here, this is your great expectation data frame, and they are identical look like. It means underneath the great expectation, the pandas is also in play, and the great expectation is depending on pandas to read the pandas data frame and process it accordingly. So now the question comes that what if there are other data frames? There is Spark data frame. There is a TensorFlow related data frame. So how you could do it? And the answer is that yes, depending on what is your source data frame, which is supported by great expectation, it actually reads accordingly. And I do have a tutorial related with Spark data frame with great expectations. I will be coming there a little later, but at this point, what I want you to understand is that depending on in your configuration, when you are creating the context, you will tell great expectation what is the source and the data type, and that where the great expectation will try to understand and read it accordingly. So here we are reading the source URL and now the data frame, which also has the great expectations modules available for you. So here is our data frame, and here are the various columns and the data according to that. If you would want to see the details related with great expectation, you could say that df dot, let's see what happened. And here is your data frame. So for the numerical classes, you are getting all that information available for you, but you also have the text or label classes like a sex or this name or the ticket ID or the embarked cabin. So those columns are not being understood. So there is another tutorial I have created recently using the data profiler for pandas, and it's called the panda profiling. And that tools could be very helpful for you to get more details about this data frame. However, the difference between the great expectations and profiling tool is that how you are trying to create the rules related with your data. So very first you are saying that, oh, in this data frame, I want a fair column must be exist. And here you could see that fair is success. If you look into we want to have the column fair. Here is a fair. If we say column fair X, it's going to be false. So for individual column, because expect column to exist, so you need to pass one column here. If we try to say expect, and you can look into expect column, and you can say, and you see here there is no columns. So expect columns, and the columns, when you are trying to use multiple columns, is better to supply the array of the columns. So here you could say expect column to exist. So if you want to use the same expect column to exist, and you can say that age, and it will tell true or false. So for each and individual column, you have to validate that particular column expectancy. After that, if you would say that expect column to exist not found, and it will say it's false, it's not found. Next, you can look into the individual value available in your data set. And here you could say we are expecting that fare must be between 1 and 1000. And as you could see here, there are 891. There are 15 values. Actually, they are not true because those 15 records shows the value is set to 0 and our minimum is 1. So that's how you are going to see the success is false. However, if you say fare between 0 and 1000, now it's become true because everything is between 0 to 1000 in between. So that's how you are going to understand that how the numerical values are according to your domain expertise. Next, mostly 80. It means now you are saying that out of this value, the 80% should be correct there. And if we say that these should be 99%. So you could define whatever is your logic is according to your data requirement. Now we have another validation, expect column values not to be null. And if you look into the cabin, there are 687 values. They are actually the null. It means they are not available in the data set. And that's how you are going to look into it. Here is another way to look into the column values. They are set. So this value in column sex must be between male and female. And that's going to check and it say if there is any error based on that. So that's how you could create as many as expectations related with your column. And the best way is you can look into expect and tab and you could see there are tons of expectations available. And depending on what you would want to do, not null, match, not match regex, regex list, columns to be unique. If you have names or if you have keys, you make sure that those everything is really unique or not. There are keys, they must be common or not. Multi-column, sum to the equal. There you go. So you can do aggregation also within your given data set. So there could be several things you could do. And the idea is that at least you got an idea that what it is and how you can get started with great expectations. Now get expectations config. So let's take a scenario that you are the domain expert and you have created all these expectations. So they all are really being done in a way that they are actually written in the configurations. So if we look into the get expectation config, and if you see here, this config object actually has the great get expectation config result. So let's try to look into what is inside config. And you see here, there is everything what we have done in past has been recorded and those values are added here. So you see that expect column value in set, it should be there, here is, and that's how is really being configuration. So it is just a configuration which is being recorded as we were working. But in real work, you are going to create these expectations and you save them as a configuration already, like a pre-existing condition during your data exploration phase. So these configuration will be there. If you would want to save these configuration, you could save them. And here is the saved configuration is just saved by us. And if you would want to take a look, you will see that exact same configuration what we have. You can reload it. That's become your new config. So get expectation config, we are reloading it and that's the new configuration. And if you would want to validate your data based on configuration, you can use this as a new data set. For example, if we had a new data coming and we want to validate, we can use an existing configuration and we can validate. And here is the validation and here is the result related with validation for each configuration related with the expectation was created in the great expectation config. So there could be several things you could do, and this is just an example. So the example list could be really very big. So here this select column values to be unique within record. So if you see the name, everything is all unique, there is no problem. But if we look into the tickets, everything is unique as well. At this point, you should have an idea about what great expectation tool is, and if you would want to use it, how you can get it started. And as I mentioned that my another tutorial is going to have the in-depth detail about how you can create your expectation related with the data set, and then how you can apply that for the new data set. That when we understood that, one thing comes in our mind. We do have a lots of data which is really time series data, shopping data, your website consumption data. So time series data is almost everywhere. So how you could use the great expectation with time series? So I do have this example where I am using one of the supermarket sales data, and then we are going to apply the great expectations tool on the time series data. So in this Jupyter notebook, we are going to apply the great expectations on a time series data set by applying few of these date specific data validation. So let's import the pandas and great expectations using this data source. We are directly using the great expectation to read the data frame, and here is the sample of data. So you could see here we have a date column, and if you look into the df dot describe, these are all the numeric column. So looking into this date column, you will be able to see that this date column is actually the string column right now. As you could see here, I'm using this called the method from great expectation is, again, it's a rule that expect column value to match strf time format. So this is the match, okay, and then here you see df, and here you could see that element count 1000, unexpected count 1000. It means we are expecting the date should be in this format. However, the date is in this format. So its date is basically mdy. So if you would want to fix this, you could say, okay, let's check this way. It doesn't have time. To remove the time, it has m, then it has d, and then it has y. And here you could see that in that way, result expectation is false, success is true. It means all the values we have, there is no missing value. All of data is format like that way. If we just put one space here, and as you could see here, immediate error happened because that format got changed here. So we have to make sure that the format our data is, it has to be understood correctly when we are writing the expectation method. Here is the column, here is the format. So you have got very quickly this idea that how you could use the date related logic or validation logic with your data set. So here is a expect column value to be date util parsable, and as you could see here, it is true. So it means that the date value is a parsable, and that's why it is. The results are true. If we try to use that value with a column name total, and as you could see here, because total value is not anything related with date. So this way, very quickly you could understand that if the column you are asking is related with date or not. So this is the, at least it's validation related with column first. After that, you could make this call, because if the column has the date value, then it could have one of the format related with date formats, which are acceptable formats. So we have seen that. Next, what we are trying to do is that we are converting that string date format, and we are setting the new column called the date time. Here is our date time. So let's use the df as again. And here is our new date time column. And now you could see here that this was the string value, and this is the actual the date time column now. So now if you try to use the date time column here, and if you say, okay, let's try to use this first here. Let's run, you are going to get error, and let's take a look into the error. Values passed to expect column values to be date util parsable must be of type string. It means when you are passing the value in the column, it's actually a date time type. It's not the string type. It means if you are trying to use this, it has to be string, and reason is that because the format initially was given, so the expectation is that the column should be the date format in a string. So that's how you get an idea. Same thing when you are using this. So when we are here, when we are going to run this thing, we already see the error. Next, we could see here that when we are saying that expect column value to match strf time format, if you are trying to process that with date time, you are also going to get that error. So make sure you understand that part when you are processing the date related data in your source data set. So in this step, we are going to look how we can use the great expectation with the other data frame which are not Pandas data frame. And for that tutorial, I already have the Pyspark installed in this machine. Here we could see that Pyspark is already there. For those who are new, they could install Pyspark using this command. I am importing Pandas and great expectations here. And in the next step, I'm importing this Spark session method to create the Spark context. So now I will have Spark context available for me, which I could use it subsequently in this tutorial. So very first thing, I'm just creating this data object, which will be used to create the data frame depending on what we are trying to do. So for example, Spark has a Spark data frame, Pandas has a Pandas data frame. And if you are using the H2O.ai machine learning open source library, they also have something called the H2O data frame. So depending on what data frame you have to properly work with great expectation tool accordingly. And here we are going to look into for the Spark data frame. So if you are trying to create a Pandas data frame, you already know that you need to pass your data and it's from dictionary and it creates the Pandas data frame. So here is your data frame, which we have just created using raw data. And this is the Pandas data frame. Now, if you are trying to create the Spark data frame, so here you could see that we are taking a Pandas data frame and converted it to a Spark data frame. So spark.create data frame, and we are passing the Pandas data frame here. Spark data frame is say data frame. These are value, and if you want to see the data, so this is Spark data frame, and here is the data which is similar to that. But this is totally the Spark data frame, and this is how we could validate it. So now you could understand that what is a Spark data frame is going to be look when we are going to process it with great expectations object. So here is the great expectation, and is say with Pandas we create the great expectation object like this. So here we have the Pandas data frame, and when we are trying to read the Pandas data frame and making it a great expectation frame, this is how we are trying to do. In the previous example, actually here we have read the source directly with great expectation object. However, if you already have a Pandas data frame, you want to convert to the great expectation data frame, you can do this way too. And here is our great expectation data frame, which has the Pandas everything plus the great expectation methods also. So now if you would want to create the great expectation object with the Spark data frame, here is the GE data.dataset and Spark df dataset and passing the Spark data frame. And now you have the SDF which is the great expectation dataset for Spark dataset. So now you can apply all those great expectations method on a Spark data frame with SDF data frame object. And now everything is become same. So if we try to look into this object SDF dot expect and tab, and as you could see here, everything is available for you. So it is very much possible that there could be one or two extra methods which are available on here which may not be available in the Pandas data frame. I really do not know, but this is how you are going to use the various methods available in Great Expectation and apply to SparkDataFrame. We are using the status column, which is status, and check if there is a null or not. And here you see 4 unexpected ones. So one of the column means 25% of the column are having the null value. If you want to test price, must be between 1 and 100, and you are going to see that yeah, there is a one value which is 200. But if you say it is 250, you will have no exceptions. Means your expectations are met. So if you have 100, you are going to get that. Expect column to exist, price is false, and reason is that because it doesn't accept the array. So you have to make sure you are accepting this. So actually I should leave it that, and that would be a great example. And it's true. So that's the correct way to do it. So now you have got the idea how you could play with SparkDataFrame. However, if you just still want to have the capabilities of Spark methods on the Great Expectation data frame, here is something you could do. So if you see, this is a Spark data frame. It tells how many rows are there. And if you try to run this count method on a Spark data frame, which is Great Expectation, you are going to get error. So if you want to have those functions related with the Spark data frame available for you, you could call the Spark df. So Spark data frame Great Expectation object dot Spark data frame plus count, and that's how you are going to get it. So this pretty much covers for you that how you could use Great Expectation with your Pyspark data frame. So as we grow further in our journey with Great Expectation, there is a lot to learn, but for beginners, at least we have covered this part. One big thing I would wanted to share with you is that depth expectation, and that really proves the power of Great Expectation tool. So here, this depth expectation is basically a support of Great Expectation to depth test macros. It means that the core Great Expectation has been enhanced to support the depth macros. So here you could see the methods are available. So these are the test, expect column to exist. Most of these methods are already, we have seen one way or another. String match, aggregation. So here you could see that these are the aggregation method, multi-column, across distributional function. And so these are the methods available related with, and here is the depth expectation. So if you would want to use that, you just need to pip install depth expectations and you will be good to go. I would suggest you to look into this section, like a building your first depth model related with depth expectation. So once you install everything, you have this thing available, you can build your very first project related with the depth model. So I will let you take care of this, and that's something shows you the power of Great Expectation in a particular domain. Tomorrow, if you would want to test your machine learning models related with a particular business problem, for example, you are doing a price prediction for a retail data set, you can build the Great Expectation library specific to your model, and that can be used during the EDA phase as well as when the machine learning models are being used to generate the pricing or predicting the pricing. And you can validate your data. If everything comes within your validation, then you will feed that data into the machine learning model to predict. Otherwise, you already understand that the data you are giving to machine learning model does not really validate. It has several problem or some problem before you could use it. So let's review what we have learned in this tutorial. We understood that Great Expectation is a great tool for data testing, data validation, and it expands its reach from EDA or from the early data profiling or the exploratory data analysis and all the way to the data in production. And Great Expectation can be used with available methods which are already part of Great Expectation library. However, if your data is very different and it needs a very different rules or very different methods to be made for the data validation, then you can expand the use of Great Expectation Library and make it whatever needed to match with your own data validation requirement. So it can be expanded. We have looked the initialization phase, installation phase, initialization phase, and also the getting the context. And after that, we looked around a few examples such as Titanic dataset to use various methods available in Great Expectation related with data validation. We also looked into the time series data set. And finally, we also learned how the Great Expectation library can be used with different kind of data frames such as Python Pandas data frame as well as the Spark data frame. We also looked about one very useful library called the depth expectations, which is a new library which extended the reach of Great Expectation library in a very different domain related with depth map. So that's all I had for you to share in this tutorial. Very soon I am creating another tutorial where we will be using the Great Expectation tool in a manner where you are going to write all that logics related with your data, everything as the exploratory analysis phase, and then we are going to use that exploratory analysis configuration to perform on new data to validate whether data is good enough for us to use it or not. So that tutorial is coming soon. Until then, I'm glad I have you in this tutorial, and I'm looking forward to seeing you in my another tutorial. Thank you. That's all, my friends. If you have enjoyed our content, please like it, share it, subscribe it. And finally, please remember, be good and do good. Thank you.